So is this true? If I have the cosine of a plus b, is that the same as cosine a plus cosine b? In other words, can we distribute a trig function?
Yes.
Seems reasonable. Everything we've done, tells us distributive property works. So let's try it something. Let's say I did cosine of 30 degrees plus 60 degrees. So if that works, that has to equal the cosine of 30 degrees plus the cosine of 60 degrees.
Right.
Correct? Yeah. Okay, let's work the two sides and see if they're the same. What is 30 plus 60? What is the cosine of 90? Because it's the square root of the bottom over 2. Okay, what is the cosine of 30?
Oh no.
What's the cosine of 60? So you could write it as a single fraction, but does that equal 0?
No.
No, most definitely does not. So, distributive property doesn't work with our angles. If our angle is two terms added together, we cannot just take the trig function to both of them. We have to have a formula for that.
But aren't you supposed to distribute before you add parentheses? Or you do the inside of the parentheses?
If you're really curious where these came from, I can show you whole proofs why these work. But this is how we can break them apart. So this is on your flip chart, your first two sum and difference formulas. So we have a formula for cosine of a plus b and a formula for cosine of a minus b. I'll let you guys write those down. These are on the formula sheet that you will get on every test and quiz, so you don't have to memorize them. You have the cosine of two things added together. Cosine of the first times the cosine of the second minus sine of the first, sine of the second. When it's subtraction, all it does is flip the sign in the middle. So we are going to use these formulas for the rest of the day today. If I asked you to find the exact value means with radicals, not with decimals, of cosine 75 degrees. Is 75 degrees one of our common angles we have from our hand trick?
No.
No. So if we did our calculator, though, it's going to give us a decimal, which is not what I asked for. We are going to rewrite it. Can you do 75 as two angles we know added or subtracted?
30 and 45.
Okay, so then if we do the formula, it's cosine of the first, cosine of the second. So we're looking just at this a plus b because we did 35 plus 40, 30 plus 45, minus sine of the first, sine of the second. What is the cosine of 30 degrees?
That's square root of the other 2.
So these don't go away. We haven't used the hand trick in a chapter, but it's back. Cosine of 45. Tangent is 1. Cosine is the square root of the bottom over 2. Sine of 30, so square root of the top over 2. That's 1/2. Sine of 45, square root of the top over 2 is radical 2 over 2. So we get radical 6 over 4 minus radical 2 over 4. You can leave it like that if you prefer to make one fraction, radical 6 minus radical 2 all over 4, that's fine. But we don't want the decimal because I said exact value.
I feel like this goes against all the maths.
Well, not really. If I say like the square root of 9 plus 16, you can't do the square root of 9 plus 16.
No, I mean the distribution.
I know, but it's kind of like the trig function is kind of like the exponent. You those distribution rules don't apply.
They should. Come on.
Alright. Cosine of 17 pi over 12.
Maybe it's in radians.
It's in radians. I don't know about you guys, but for me, it is a lot easier for me to think like 35 or 30 plus 45 than it is to think pi over 3 plus pi over 6. Am I alone, or do you guys agree with that?
I agree.
Okay, do you want to change this into degrees?
Yeah, 180 over 5.
So these pi's cancel. 17 times 180 divided by pi, or divided by 12 is
255.
okay. It might help you to have a unit circle out if you want to look at, because am I going to get 255 just by 30, 45, 60, and 90? No, so I need to think about the entire circle, so you might pull one out if you need to. But we're thinking any two angles on the unit circle that would either add or subtract to 255.
225 and 30.
225 plus 30. That is not the only possible combination. So if you had a different one, that's okay. As long as they add or subtract and they're on our circle, we could do that. You could do like 315 minus 60. Those are both on there. They subtract 255, so different combinations. Because I chose two angles added together, I'm using the sum formula, which is cosine of the first, cosine of the second, minus sine of the first, sine of the second. Alright, 225. What two pieces of information do I need to think about?
Quadrant and your reference.
What quadrant is 225 in?
Third, fourth.
It's between 180 and 270, so that's quadrant 3. Reference angle, 225 minus 180 is 45. So, in quadrant 3, is cosine positive or negative? Okay, what's the cosine of 45? 30 is in quadrant 1, so we don't have to do the quadrant and reference angle. So cosine of 30 minus, okay, 225. We already said it's in quadrant 3. In quadrant 3 is sine positive or negative? Negative. What is the sine of 45?
Square root of 2.
And the sine of 30? Radical 1 over 2, so 1/2. Okay, if I multiply this, I get negative radical 6 over 4 minus a negative, so plus radical 2 over 4. You can leave it like that. You can put it in one fraction. You can,
You just repeat the negative, so it's not. Oh, we can flip it up.
if you don't want the negative in front, you could change the order. Is there a way you could double check yourself on these?
Can't you work it the other way?
Okay, could I, if I wanted to do the original, would my calculator have to be in degree or radian mode?
Radian.
Okay, let's try it. So put our calculator in radian mode, and then do cosine 17 pi over 12. And we get a nice, lovely decimal. And now let's type in our answer. Negative square root of 6 divided by 4 plus the square root of 2 divided by 4. Do we get the same long, ugly decimal?
Yep.
Yes. So you can always double check if you need to. Is that okay?
sure? Oh, it's only in front. Oh,
This doesn't have things that could add.
No. We don't have two things on our circle that add to 173 or subtract to 173.
Oh, we could undo it.
Okay. Cosine cosine plus sine sine
It's subtraction.
looks like this, doesn't it? That's the cosine of A minus B formula. Okay, what is my A? And my B?
83.
173 minus 83 is?
90.
And what is the cosine of 90?
0.
Are there any questions about using these formulas so
Did we not do the second side?
far? This was all part of it. So the cosine cosine plus sine sine, both of those were in the formula. Anything else? Let's try a proof.
Oh no. I mean, yay.
Better answer. Which side would you box in?
The right.
So for the left, what would we have to do?
The reload.
It's 360.
Or we could.
It's not just.
Yeah, it's just 360.
Yeah. Do we even? We don't
No.
necessarily have to do
Because
that.
we're just distributing. We're doing the distribution.
We can't distribute cosine.
So just turn it into the.
Yeah, so I mean,
The
we
formula.
do the formula.
Identity.
So cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay, cosine of x, not much I can do there. Cosine of 2 pi.
0.
2 pi is the same as 0. What is the cosine of 0? 1. Radical 4 over 2, so 2 over 2 is 1. Minus sine of x times the sine of 2 pi. So that's the same as the sine of 0, which is,
I keep thinking it's on.
yeah, sine and cosine are never undefined. It's only between -1 and 1. So we get cosine of x minus 0, which is cosine of x.
Do we need to show the cosine of x minus 0? Okay.
I would ask that you showed this step so I
Right.
can tell you evaluated. Other questions? I want you guys to see if you can do this one.
Oh.
You're not. So what's it turn into?
Cosine 5x.
This is the cosine of a plus b formula, so 3x plus 2x.
Your handwriting looked just really beautiful right there.
Oh, thanks.
I just, the whole thing.
It's unusual.
It's not, but it looked really pretty then.
All right, is that one okay? Did you get it? One more proof.
Oh, you just gotta read it.
Secant of 3 pi over 2 minus x.
Can we change it before we box it in? Like, can we make it and turn to sine cosine?
No, keep it as the original one.
These will work both of them into a formula.
All right. Which side would you box in?
Right.
Do we have a formula for secant of a minus b?
No, but it's the reciprocal of cosine.
So I could say secant is 1 over cosine of the 3 pi over 2 minus x. And then if I use my cosine difference formula, it would be 1 over cosine of the first, cosine of the second. The second one isn't negative x. Okay, the negative just tells me I'm using the subtraction formula.
Oh, everything is over, like it's not, okay, I understand.
Plus sine of the first, sine of the second. Is everybody okay there? Alright. Let's see if we can evaluate this. 3 pi over 2, if you're thinking about your unit circle, it's here. What's this point?
2, 7.
Lower pair is 0, negative 1. What is the cosine? 0 times cosine x. What's sine?
1, negative 1.
So 0 times cosine drops, negative 1 times sine is negative sine. Okay, we have a negative. What is 1 over sine? So we're not going to get sum and difference formulas for secant, cosecant, and cotangent because we don't have to have them. We can do it as the reciprocal of sine, cosine, and tangent. Any questions? Okay. So that's my stopping point. I want you to practice this. Tomorrow we will do the same thing with sine and tangent.